So, welcome. Yeah, I'm planning on making this hopefully a kind of regular type of content that I do. I want to tackle some level 1 stuff. Most of it blind. The one that I'm doing tonight is not blind. I did a bunch of the Cryptopals stuff back in 2013, so 6 years ago. But never prepared. I don't want to have a lecture. I want to have a chance to let people see what it's like when I'm approaching challenges, either completely blind to them or fresh. Give everybody who's around chances to ask questions. Yeah, hopefully it should be good. Tonight, I wanted to do one of my favorite bits of technical stuff that's ever been made. I've always called it the Modisano Crypto Challenges. Now it's just Cryptopals Challenges. Because Modisano, some folks from that company were involved in its creation originally. Now the stewardship of the challenges have been moved onward to NCC Group. So, Cryptopals Challenges. Crypto, no, not as in cryptocurrency. This is specifically focusing on cryptography. So, specifically cryptanalysis. Now, the level 1 challenges are pretty darn easy, like 101 level stuff. In fact, a long time ago, when I was helping other people learn how to program, once somebody hit like somewhere between beginning and intermediate proficiency with a language, this is one of the places that I would tell them to go look. It's a great way to learn a language. It's a great way to get proficient in that language, and also it's a great way to kind of cement a lot of the sorts of things that, you know, not in level 1, but later on, a lot of the ideas regarding why maybe you shouldn't ever implement your own crypto. Yes, crypto as in cryptozoology. That is absolutely correct. But yeah, let's get moving on it. I should have given this virtual machine more CPUs. There we go. Alright, so we're going to be doing the Cryptopals challenges. Stuff is real great. I am going to point out, you don't need to know a ton of math. There is advanced math that's involved in some branches of cryptography. But for something like what we're doing here, especially for set 1, you don't need to know advanced math. You need to know how to do XOR. That's it. So let's hop on. Let's take a look at set 1, challenge 1. Alright, so important note there that's not reflected on the overlay, but we always want to operate on raw bytes, never encoded strings. This is good to know. You want to avoid operating on, well, you want to avoid operating on encoded stuff. It is possible. It makes your life harder. What if you don't know any math? Asking for a friend. Good news, XOR is barely math. right. So we're going to have a string. I'll pull up the browser aside over here so that I can have it handy. So let's I'm going to use Ruby. No reason to prefer one language over any other. If you are following along at home, use whatever language you want. I'm going to use Ruby. All right, so we've got a string. We expect this string to produce this result. So this is just converting hex to base 64, which is what that said in the title. So obviously this first string, we'll just take the first, let's say, 3 bytes of what we've got there. 49276D. So the idea here is that this is actually there we go. This is actually just a collection of bytes. So here we've got the actual bytes separated into themselves. These are hex values, so when you see 49, that doesn't mean 49, that means 73. So, and so on and so forth. So the idea here is that we want to take these bytes, we want them to become their raw string form, and then we want to be able to encode that into base 64. Ruby has the base 64 library, which makes it real simple to do that. So not a big deal there. All right, let's catch up in chat before I carry on though. Oh, I'm glad if the Ruby is going to make it easy to follow along. Yeah, it's one of the reasons that I wanted to use Ruby for this stream specifically. But anyway, so let's walk through what I did there. So X itself is just a string of characters, which I split out with chars into an array of characters, a list of characters, however you like to think about it. I then called each slice on it, which is a Ruby method on the array class, which gives me an enumerator, which I can coerce to an array with 2a. And that gives me tuples. So now I've said, give me groupings of 2 characters. And that way we can, because OXFF is the highest hex value, so that would be 2 characters, as you can see. It's also the highest amount that you can hold in a single byte, 255. So that's one of the reasons that it's quite nice to work with hex. But anyway, then we can take that, we can map over that. So what map does, for anybody who's not familiar with that terminology, people who work in C, C++, and so on, what map does is it takes a function. In this case, we're saying the join method, which exists on an array, and it calls it for each element of that array. So for the array 49, which is an element of the array that we're calling it on, it's going to join those. We'll get the string 49. ditto 2.7, and then ditto 6D. Shevik, yes. RB is Ruby. So I'm going to take a moment to catch up with chat, make sure that everybody's following along, ask questions. Item pouch, that's a bummer. I am sorry to hear about that, and I hope that the car shopping at least goes well. You were foolishly planning on using JavaScript. You know, due to the fact that JavaScript encodes integers as floats, I don't know if that's necessarily, I don't know JavaScript very well, so it wouldn't be my first choice. I don't know if you would run into any problems. If you do, I would love to hear about them. I have to assume that at this point, something like what we're going to be approaching today is pretty trivially doable in JavaScript, but I can't speak authoritatively to that. Could I please do this in 6502 next time? Man, I never learned 6502. A long time ago, I used to kind of know 68K, but I never learned 6502. Alright, so at this point, what we know is at the end of the day, we know is that we need some function that takes that source string and gives us a destination string. So at this point, I'm going to say let's go ahead and does it include path? I'm actually not sure. Nope, certainly isn't include path. Well, this modifies my include path. Sorry, I don't actually remember the non-sigil way of doing it. You could do this in 68K? Yeah, totally. When I was doing these originally 6 years ago, I was first doing them in Ruby at the time, and then I was doing them in C, and then I was doing them in Erlang, just because I found it really interesting, the differences in the approach that you would have to take. I'm not going to worry about that, but let us definitely I'm going to start making some helpers. Why do we use a tuple here? I'm not sure that we are using a tuple currently. Oh, thankfully the include path for base 64 is part of the default path in Ruby. No, I didn't want to have to pass a flag to include the lib library. All right, so what we did before was pairs. In fact, we can so now if we pass incomplete bytes, it is going to raise an argument error, gives us a little bit of information about whether or not we're passing well-formatted strings. In fact, 2a is not necessary here. Since I'm going to have to call map twice, I'm just going to do this. All right, so this hex string should give us 0, 1, 2, 3 when it comes from hex. So if I'm not a complete idiot, which I am, fantastic. Aha. Cool. So we can now decode hex. Delightful. Then, likewise. So this one's kind of superfluous, but I like having it here in this case just so that everything that we have built, everything that we're working on is just going to be kept in one place. Due to the fact that, as you can see, completely worthless to actually have it there. But we now have in fact, let's go ahead and remove that. That's self, and
I see the beauty in you.
this is interesting, but you don't know what's going on. Is this how games are made? I mean, overall, the process of programming certainly is involved in making games. Currently, what we're working on is some cryptanalysis challenges. This is some content that I wanted to do to help people who might be interested, who wanted to get just an idea of what it's like to get started. Give people a jumping off point. All right. Failure. Wow. Cool. The strip method is quite important. It's quite handy. So let's say we have a string, and it happens to end in a new line. So that new line, when we print it, means that we now have, you know, just an extra space on the terminal. Quite important. Base 64 in code 64 adds a new line by default, so that's almost certainly what's going on. Alright, yeah, so it's giving us clean lines. You can see that it's giving us clean lines. If we look right here, we've got that new line character in the middle of our string. And that is probably so that you can pretty print it. When you're decoding base 64 strings, new lines are completely ignored. So it's not going to be harmful for encoding and decoding from the base 64 standpoint. But since we're doing a direct comparison with double equals, it's not going to be real happy about that. So we will split it by lines, map it to strip. Again, strip removes leading and trailing white space, including new lines. And then we're just going to join that back. And hopefully Yep. So that lines does do exactly what I was hoping it would. So now we do that test again, and we've got success. So, brilliant. We've done this step 1. This is our first challenge here, which is just being able to convert hex to base 64. This is the sort of thing where, realistically, getting a hex-encoded string is relatively rare in the real world. Understanding how to work with base 64 is useful all over, really. Not just a cryptography topic, that one. Alright, so before I move on, I want to give everybody in chat a chance to ask questions. This is not even really crypto related yet, so oh, that's very kind of you, Crochet. I'm glad if my IRL streams are fun. I want to do more of them, so. All right, well, I don't see any follow-up questions in chat, so let's go ahead and move on to challenge 2. Alright, so now we're going to be looking at fixed XOR, which is just a function that takes 2 equal length buffers. When you hear buffers, you can think strings, and produces their XOR combination. So For those of you who do not know, XOR is exclusive OR. It works on individual bits, so values of either 1 or 0. 0 XOR 0 is going to be 0. 1 XOR 0 is going to be 1. Likewise, 0 or 1 would be 1. And then 1 XOR 1 is 0. So it's only going to be true when one or the other is true, but it will not be true when neither or both are true. So XOR ends up being very useful in a lot of different branches of computer science, cryptography being one of them. And so here we're hoping to just build a function that's going to take two strings and XOR them together. Ruby does not have XOR by default. There's a few ways that we could go about doing this. If we were so inclined, we could just open up the string class and then build an XOR function into it. I'm going to go ahead and just write out in our strings module, since we're already building out this helper module, I'm going to write an XOR AB function. Okay, so here double check something. Oh, that's going to make my life a little bit easier. How nice. Alright, so let's talk about zip real quick. Zip is a super cool function. I'm going to give myself two arrays real quick. 1, 2, 3, and ABC. And I'm going to zip these together. So what the zip function does is it takes two arrays and it gives you two tuples of the 0th index, the 1th index, and so on. So we're able to use that to build out some pretty nice functionality if you're used to thinking about things in a Lispy functional way. So now that we've got our zipped value here, we're going to map a function over it. And we should be able to just map XOR over it. And you can see now we're about to map another one, which instead of giving ourselves, and of course it's not, it's a constant factor, which is less bad than, you know, changing our scaling properties. But since we have two maps immediately next to each other, may as well just go ahead and join them. All right, let's go ahead and test that out. Alright, so if we XOR A and A, because they're identical, we expect all zeros. Brilliant. Now if we XOR A and space, we expect, because space is x20, it just so happens to toggle whether or not it's capitalized. So this looks like it's working correctly for a single character. Let's try it with multiple characters. Looks good to me. So overall, I think that our second challenge is going to be done pretty quick. All right, so the instructions say that we want to feed it the string A after hex decoding and XORed against B, which looks to also be hex encoded. It should produce this string R, which looks to also be hex encoded. So our test string is going to be, in fact, let's just make this real easy. And so I like to use, in Ruby anyway, underscores in place of where I would in Haskell be using apostrophes to indicate that it's prime. So we've got an A, and then from hex A is our A prime. Before we go and continue checking, let's see. Nix, this isn't really stuff that's particularly high level, and that's kind of what I wanted to get across. I made a point of not preparing for the stream because I didn't want it to be a lecture. I wanted to, you know, stumble and show that, like, I'm an idiot too. Everyone's an idiot. Unless you're practicing something over and over and over again and turning it into a lecture, it's, you know, it's just part of the process. Are Ruby and Haskell the big crypto languages? Not really. In fact, due to several properties of either of them, they don't tend, to my knowledge, to be used for implementing cryptography. Today, a great deal of cryptography is still implemented in C. I'm aware of a decent amount of cryptography being implemented in Go. And I believe that there's a push to implement some cryptography in Rust. But in this case, we're not directly implementing crypto, and we're certainly not going to be building crypto that's going to be in active crypto systems. Later on in the challenges, you do build out crypto systems, but you are specifically building them in a way that is known to be flawed. So the expectation that you would ever use them in the real world just isn't there. And that's one of the reasons that you get to use kind of whatever language you want to do these challenges. In this case, the logic is way more important than necessarily what language you're using. Aha. So we previously had from hex. We do not yet have to hex. Time to fix that. That should do it. Actually, 1, 2, 3. Dot lights, dot map. This should give us 33.13233. Brilliant. So now, hey, cool. All right, so that's step 2. Step 2 was pretty quick just because a lot of step 1 taking a bit was just kind of set up and getting things moving forward. And yeah, it's all about fun and learning. So there we go. That's step 2, which again, there's not a lot to this. And again, this isn't really, you know, doing anything crypto-y yet. We did an XOR of 2 strings, but I mean, taking 2 buffers and XORing them is not, that's not something that crypto owns. Like, if any of you have ever used a RAID 5, then you've been using, you know, 2 buffers XORed for a very long time. Yeah, XOR is very much, hey, we've got to start somewhere, and making sure that you can work with that is really important later on. How do strings work in Ruby? Is it like Python or C or something else? It's closer to Python than to C. By default, all strings in Ruby are going to be encoded UTF-8. I am kind of playing fast and loose with that up until the point where I get bitten for it. I could be forcing encoding on everything to ASCII, but until I'm bit for it, I don't care. But no, that's a good question. Strings, like in Python, they're an object, which means that I've got methods on them that I can use. Bytes being one of the nicer ones to use. Likewise, I can coerce them into a list of characters. So at that point, it feels a lot more like C strings, although, you know, when you're dealing with a list of characters, they're not numbers yet, but you can coerce them, a given character to a number by taking its ordinal. But yeah, any more questions before we move on to question number 3? All right, question 3 then. So this is our first. Like, this is definitely a crypto question. So we've got a hex-encoded string. It's been XORed against a single character. We're going to figure out which of the possible, I mean, I could say 256, but realistically 255 if you're XORing against null. It's not going to be super helpful. But we're going to figure out which... We're going to figure out which of the characters it is. So, yeah, we can do this by hand. Anybody who's gone through... there's a bunch of books on really, really old cryptanalytic methods. So this is getting into one of the older methods, which is called crib dragging, where you take a key and then you just drag it across the entire ciphertext, just trying to figure out, hey, is it possible that this is going to be the expected key? And you look for usually tuples, 2 tuples, 3 tuples of common letters that tend to show up together. THE is very common, for example. A and D is another really great one. But for now, we're going to be just trying to create some rules that we can use when we just throw a byte at a given ciphertext, and we're trying to figure out a single XOR against it. Some rules that tell us, hey, this is maybe good, or this is definitely bad. And I'm going to take this one pretty slow, because I want to give, like I said, I want to give a lot of chances for people to ask questions. At this point, we're starting to move into proper cryptanalysis. This is, one of those things where it's maybe still kind of 101, but you got to start somewhere. Lila Veer and Skolgan, thank you so, so much for 16 months and then 23 months at tier 3. That's incredibly generous. Earlier, JT Norimaki, thank you so much for 16 months. And then Crochet, if you're still here, thank you for 22. Just a reminder, like, all the money that I get from this stream gets passed along to the Extra Life charity drive that's linked in my stream info. So that's super, super generous, and it makes me feel really good. But you're also helping out sick kids, and I hope that makes all of you feel really good. What does the question mean by scoring text? That's a really good question. So I can give one example just off the top of my head. If we had... I don't know what OX72 is. We'll find out. If we had this string, which looks like that, it's R. If we had R, XF1, 1 space, XFF, that's not really a printable string. I guess it looks like R1 because we've got non-printable characters in there. That's not a very good string, though. Like, not at all. That's not going to be super meaningful to us. We should figure out how to write a scoring system that says this string is BS, and we don't want to care about it. This reminds you of your computer security class in college. First half was super crypto focused. Wrote a bunch of basic crypto programs. That's super cool. I'm really, really glad that universities now are beginning to incorporate a lot of InfoSec topics just in the core curricula. I think that it's something that is very important, and it makes me thrilled that that's going on. But yeah, welcome, Math Jargon. I absolutely love your handle. EFE8493, clicked here randomly and impressed with explanations. Thank you. Yeah, this is something that is a passion of mine. I've been wanting to just tackle a bunch of level 1 topics. Like, this one is just the beginning of the Cryptopals challenges. I'm going to do some others, CTF, stuff like that. Just because I've talked to a bunch of people who want to get started and feel like they don't have a jumping off point. Can I brute force your name? It's a hash. Joking. Fair enough. But yeah, so we're going to figure out some rules. We're going to figure out some rules specifically to make it so that when we come across text, we can say this is more likely to be English, or this is less likely to be English. And I mean, I already gave a really good one. I think that we should say non-printable characters, minus 1,000 points. And while I am happy to walk through any thoughts that I have on this one, like I said, I want to be really, really slow to push forward on this, just in case anybody wants to ask questions, give suggestions, so that we can talk about all of the different ways that we might go about solving this one. Now work for a company where security is super important. Shocks you how many holes are in modern systems. Software's hard. I mean, that's the bottom line of it. Software is very, very hard. It's easy to accidentally, it's easy for people who are extremely seasoned, good programmers to end up with bugs in their code. We gotta work together. People who spend all their time trying to find holes in software have to work together with people who are spending all of their time trying to just build software to get something done. Because otherwise, things don't improve. And that's got to be the goal for all of us. Cool Vim setup. Yeah, thanks. It's a very old Vim setup that's at this point kind of piecemeal, honestly. While I'm waiting for... I'll pull up my Vim config at this point while I'm waiting for people to have thoughts about other ways that we might score text. But yeah, some of these rules are from when I was using FreeBSD as a desktop. There's a lot going on here. And it just grows. Like all the Vundle stuff, that's from the early mid-2010s? Mid-2010s, probably. 2014, 2015. So what you're seeing be captured is a VM, and yes, it is KDE. My primary desktop for the machine that I'm streaming from is also KDE. And I tend to use Arch for my personal workstations. And then if we're talking about like production systems that I own, it depends. 10 years ago, I was really hardcore OpenBSD everything. Nowadays, a little bit more lenient on that. I use a lot of Linux in production now. That's a good question. Is our goal legible English text, or is it alphanumerics? That's a good question. We've got to answer that question basically anytime that we're going to attack a crypto system. In this case, I think that we can probably achieve both, specifically by scoring numbers neutrally, but finding other things that we could score higher or lower. So like non-printable characters, like I said, heck with them. We don't care about them. But, maybe 5 spaces in a row should be considered bad. Currently, I don't think that the string is going to have 5 anything in a row, just looking at it. But, things like that are good manners of thought. What difference does your OS make for work? I mean, when it comes to software support, BSD and Linux are very different worlds. Currently, it's at times difficult to get software that you would like to have working. That works very easily on Linux. Working on BSD just because a lot of people develop for Linux and then say good enough. Yeah, package manager, library support. Exactly. So, yeah, that's a good question, Amatrine. How we can make this evaluation as complex as we want to. Let's go ahead and... At this point, I think this is no longer in the strings module. I think that we can say that for sure. This feels like it's going to be in a different module. Let's call it XOR. Haskell habits there. Now, I think that we do require strings. And at this point, we know that we want a score for a single byte. And now we have to figure out our rules. No, it's not going to be a list. I think that we are going to make this a hash. It's not 7F. Where do printables end? Nope. 7F. 7F is where printables end. So I think that we can definitely say that anything non-printable, we don't care about it. Yep, yeah. B is our byte in question. str is the string that we're examining for this function. Is score like a sliding scale, yes or no? I'm not sure how to answer that. I think yes, but... 0 to 19, I think that you're right. Well, we might want horizontal tabs. We definitely don't care about 0 through 6, 0 through 7. I think arguably 0 through 8. But tabs, new lines, we might care about those. Carriage returns, I mean, hey, if it's Windows text, we might care about it. So I think that we can say 0 through 8 is also in that subset. What else did we have? I think 14 through... Yeah, 14 through 1F. You were asking if the score is going to be a number or a Boolean. Yeah, we're going to be coming up with numbers. That way we can have our scores be orderable. Because, I mean, let's be real, a negative 1 million score is tantamount to false, but that way we can say, here's the top 5 hits. Do you want QQQ to be worth 30 points? Well, indeed, I think that that's a reasonable question. But I think that we, in this case, and I think that the description gave us a hint that we can remain relatively naive here. So one of the things that was on the description was that we now have the Cryptopals folks permission to make Etoin Shurdlu jokes on Twitter. That's the rough. That's more or less the average, the order of how common the most common characters are on average. So E being the single most common character used in American English, followed by T, A, O, I, N, and so on. Another similar mnemonic that I know that doesn't cover all of these characters is the phrase "a sin to err," which likewise contains most of the most common letters used in English. Why do they guess STRLNE on Wheel of Fortune? Good question. Those are all characters that exist within Etoin Shurdlu, but certainly some of them are further towards one end than the other. But they don't just give you like all the vowels, which 4 of them are in the first word of Etoin. And I'll just type that in chat so that everybody can see what I'm talking about, just in case you're not following along at home. That's ETAOINSHRDLU. But to that note, to that end, I think that we can say probably we can give all of those, let's say 4 points each. Let's give those 5 points each. That's real good. Negative 1,000 is still gonna overpower in most cases. We'll give space maybe 2 points. And so the order is going to matter here, and it'll be clear why that is. But then we can just go A to Z. Can be worth, let's call that 3 points. Certainly worth more than a space. So right now, that looks like, to me, a good first set of rules. So best in Wheel of Fortune would be ET and SHR. Assuming that we are not, we're not just giving away all the vowels, yes. And again, that's an average. You can find works that'll break that rule for sure. Your average fantasy writer uses Q more than anything else if you just look at people's names. Q and apostrophe. Alright, so what we're going to be doing So here you can see if we are matching against, or if we're using specifically detect, which is a method much like select. We're just finding the first match instead of all possible matches. So we're going to be using a method called detect, which is going to return a tuple of what it was that gave us the hit and then the score, because maps are just key value pairs. Skolden, currently we are working on a single byte XOR. So we can do string. We can get the characters from the string. We're going to map that. This is going to be a char. And I think we do have to do have to wrap that in parens so we get both of those values. We're not going to use the value directly in this block, so we just assign it to an underscore. Got a lot going on in this block, but that's okay. Go, because our score is the last. So this is our string. Here's our string. Now we're going to get scores out of it. We're just going to sum them. No, Jeff, I think that it is good to be asking questions, especially in a stream where, like I said, this was purposefully underprepared so that it doesn't come across as rehearsed and so that it can better facilitate just talking with people as they, you know, ask questions and so on. Interesting. Yeah, so the last time that I used something like this, I was using a Ruby that had less great UTF-8 support. I was on Ruby 1.8. Huh. Well, that's fine. Sorry that this is off stream. I am now Googling to see if there is a method to force encoding on regexes. Well, that's gross, but okay. Let's just do... Cool. Catch up with chat. Yeah, really, that's true universally. Computing is a story of, I found the answer, and it sucks. How did I pick values for the scores? I didn't. Like, gut feeling. The nice thing about something like this is that it's extremely tunable. I figured most common is worth a bit more than otherwise printable, and spaces are, you know, worth considering as being something that's worthwhile. But I have no idea if we're going to get the right answer off the bat, or if we're going to not. We don't care about upper lowercase for this. I figure not at the beginning. We might care about it later. Like I said, these are rules that we can iterate on. And yes, as Garglestone points out, we would, of course, if we were attacking a very specific ciphertext, that would be a case where we would have some, you know, hopefully some intuition about what we hoped to find in it. And if we thought this was going to be all caps, you know, for some reason, then we would assign a negative value to lowercase characters. And likewise, if we thought this is likely to be, you know, well-written, composed sentences, then we would say, well, at the start of a sentence, so following a space, following punctuation, or on a new line, we expect capitals, otherwise we don't expect to see them, which, you know, falls over if you're using, like, acronyms or something like that, but probably not enough for that to cause the entirety of your analysis to fall over. Right now, I feel like this is probably good enough for us to give it a first go, and if we have to tune it, we shall. And who knows, I could well, like, this just might fall over and not work, so that'll be fun. He once tried a decryption exercise from a Reddit post, didn't make any sense until you found out it was French. There you go. Alright, so let's... So, we're gonna skip null. Something XOR 0 is that thing, which no reason to bother with it. So, from 1 to 255. In fact, what we're gonna do is... Yeah, we're gonna map it. Let's say A prime equals from hex A. So we're going to map this to a tuple of the key And I just noticed we're not actually XORing anything yet. So we probably want to do that at some point before actually running this. So we're not good to go. Wonder if uppercase K is used like 1,000 times more in Twitch chat than overall English. Yeah, there's a lot of emotes that start with a capital K, so that wouldn't surprise me. I think that that type of analysis on large collections of text could be really interesting. I probably don't have... I don't really have the background to be able to pull meaningful analysis out of something like that, but I would be extremely interested in reading somebody else's work on the topic. You want to include XOR? Yeah, let's include it. It's either that or we call member methods on XOR. I'm ambivalent, so let's just include it and pollute our namespace. Alright, so single byte score, key. Alright, so this gives us a 3 tuple of the key, our single byte score, and the string itself. We'll sort it by the first item in that tuple, which is going to be our score. We'll reverse that because the sort is going to be... Actually, no. We'll just make sure that we get... we might have to reverse those in terms of the sort, but that's fine. We'll take 5. The thing with XOR is that any null bytes will be the same. So 37 appears 4 times, spaces maybe. Yeah, I think that that's a pretty reasonable, reasonable way to look at it. So we were encouraged not to do it by hand. We could totally do this by hand. This is one of those things where if you haven't ever done something like this by hand, I encourage you, write a small program that takes a small section out of a book or, you know, just out of something, maybe a news article or something, picks a random byte, XORs it, you know, with that single byte, and then do it by hand. It's a really, really fun exercise. And it definitely, it gets you used to going through that mechanical motion. Doing pen and paper cryptanalysis is something that's very fun. There's a decent number of books on the topic that you can get from Amazon. I almost said the words Barnes & Noble, and then, you know, I realized that we live in a hellscape where brick and mortar bookshops don't exist anymore. So that's fun. But yeah, definitely something if cryptography or cryptanalysis is of interest to you, I would recommend, like, learn how to attack Caesar ciphers, learn how to attack, you know, Vignere ciphers, learn how to attack like the classical ciphers, which have known weaknesses certainly, but which just help you to build muscles. But yeah, so if we assume that OX37 is a space and we know that we expect the key to be, you know, OX17. But let's avoid getting down that road. Because again, the idea is that we want to practice writing out the types of code that would help figure that out for us, because while this one's easy, and while realistically, you know, we could do pen and paper for, you know, a Vineyard cipher or something, which is going to be coming up, being able to write the software that's going to help us along in that process will pay dividends later on. Oh yeah, no starch press is really great. Super, super, super good. I own probably 75% of the stuff that they published. It's extremely good literature. So previously I said, you know, when we have two maps that are immediately adjacent, it makes sense to roll them together. And for this one, just to keep the steps a little bit clearer until we have a performance problem, I'm going to leave them separate just because this gives us a couple of clear steps, and we might be mucking with them a little bit yet. So I changed chars to bytes. So now we're pulling bytes out of the string instead of individual characters, specifically because we need to XOR it with the potential key, and then we turn it into a character. And now that rules detect line can run. So hopefully this will not crash, which means, you know, first time running, it's guaranteed to crash. It's just how the world works. All right, so encode. This is one of those problems that I don't deal with nearly often enough to remember the solution to it. So I am currently on the Google machine. Hey, Cray 4K, how's it going? Colonel Pack, hope you're doing well. Hey, cool. That's all I needed. Which means that I can probably do this like I wanted to originally. Same error? Brilliant. Hey, that's better. Alright. Undefined method last for no class. Okay. Yeah, that makes sense. So remember how I said earlier that the order matters. This is going to be our fall through. No matter what it is, it's going to match that. Okay. All right. Well, we've got a minor error there. I'm going to go ahead and I'm going to guess that's our 5 worst candidates. Let's try that. And so far, not a lot that's great there. Let's go ahead and require pretty printing. And let's just not take 5. Let's give all of them. Let's pretty print that. This is going to be quite long. Well. Because, yeah. All right. We were just giving the original string over and over and over. Not what we need. All right, so let's move some of that logic in single byte score into its own method so that we can actually call it independently. ISO 8859 is Latin 1. ASCII 8-bit is technically not Latin 1, although in practice they tend to overlap. See, and now we can say single byte XOR be string because of the fact, well, in this case, because we're scoring for, yeah, this is fine. Technically with multi-byte characters that might get wonky, but I don't think it's going to matter here. So now when we call single byte score, it calls single byte XOR earlier, which does all of the work of creating that, that final string, which we can then score independently. So now we've broken out the process of XORing and scoring, which means up here, instead of giving A, we can say single byte XOR key A. So clearly we're redoing some work here, and that's bad. If this was something that we were going to be maintaining long term, that would be something where, hey, this is obviously obviously a target for refactoring. But since this is just something we're doing for fun, I don't have to care. And hey, there we go. It looks like our very top result with a score of 127 gives us cooking MCs like a pound of bacon. So it looks like those pretty simple rules. Like, these are very simplistic. Ended up being good enough for what we were doing. I think that when I originally did this 5 or 6 years ago, God, I'm old, I came up with some really, really complex rules before I was willing to even try running it. I was looking for words, I was doing length analysis on words, and turns out that was a lot of additional work that I didn't have to do back then. But before we move on to the next one, I'm gonna pause a moment, catch up on chat, see if anybody has further comments, questions, anything. Like I said, this is mostly meant to be facilitating discussion, getting people feeling like they have a good jumping off point if they're interested in something like this. You wish you knew Vim this well. When I learned Vim, it was called VIEX. Make no mistake, I'm bad at Vim. I've just been using it long enough that I pretend to be good at it really well. Can I code a better paragraph? I don't know. I don't know what that means. You're curious how well it performs if I set all positive scores to 0. That's just filtering for ASCII work. That's a really good question. Let's find out together. I'm trying to use Vim commands in my chat window. Turns out that didn't work very well. Yeah, let's find out. It does still work. It still works, and the candidate strings that we get back are different otherwise. So while I'm going to say that we do get the correct string as our top hit, we are probably getting better signal to noise with those -1000 scores for non-printable characters. Yeah, 37 was O, which makes sense because the first 3 are 1B 3737. So yeah, super early in a string, seeing 2 spaces, that would be a little bit wonky. You know, not impossible, especially if you're trying to come up with something that's going to throw people off of the scent. But you know, in the case of this, where it's an introductory thing, I can totally see why maybe they chose not to throw really weird, esoteric ways of writing out text at the very beginning. All right. So it's been an hour and 40 minutes. Let's see what the next one is. I think we'll probably tackle one more tonight. I was planning on going through all the challenges in set 1. Not necessarily all of them tonight, but, you know, all of them in probably over the course of 2, maybe 3, depending on how long the later the later ones take, just because the later ones do start going over some CBC stuff. I think CBC is tackled in set 1. All right, so 60 character string in a file. Have been encrypted with a single byte XOR. We need to find them. We need to find the one. So this one is hopefully going to be relatively straightforward. We just wrote a ton of code, which hopefully is going to help us work through this. Oh, yeah, absolutely. So the results of the phrase. So the candidate strings up here, the very first one, as you can see, with a score of, is it a score of 88, score of 127? I don't remember I think it was score first, yeah. Score of 127, 1 byte key of 88, decimal. Is cooking MCs like a pound of bacon. Is that from a song? Yes, it is 100% from a song. And I would encourage, like I said, anybody who's interested in the topic, continue on down. I'm planning on doing all of the first set, but there's a ton of content here that takes you pretty deep into crypto topics. So you will see. You'll see the lyrics popping up over and over again throughout the challenges. How is the second answer so close? Well, the second answer doesn't appear to have any non-printable characters, and it's got a ton of characters that we've assigned a positive score to. Specifically, it looks like it just absolutely packs the string with H's, with L, N, I, W, R. They're vowels and high ranking letters. So we managed to get a high score out of it, and that's kind of why I said, hey, let's take the top 5 candidates, just in case, you know, we're close to the top, but we need to tweak. It looks like for now we don't need to. We might need to in the future once we start working on other stuff. Yusanji, you like my Vim config? Thank you. Yeah, it's the product of years and years and years. So we've got a file, which let's... what keyboard do I use? I can't really lift it at the moment just because I've got some clutter on my desk that that makes it difficult. Oh, I have 2 of them because my work laptop's right there. So I use an Ergodox. It's nice. I like it. There's a picture of it in the picture in my stream info of my desk. I mean, yes and no. Tinderlove has a lot of keyboards. Tinderlove has a lot of keyboards. All right, so I assume let's go ahead and clean this up real quick. Just to make sure. Yep, cool, great. Oh, no worries. I mean, I'm sure that my keyboard is being picked up by my mic, and I'm sure that makes for really great stream content. My apologies about that. Not that there's a ton that I'm going to be able to do at the moment. Is the question implying that there is a series of 60 character strings, or just that there is some string within it that is 60 characters and single character XOR encrypted? I believe the implication of what they're asking is we've got one of these strings is not gibberish and has been encrypted with a single character XOR. So my current plan, and I'd love to hear if anybody has a different take on it, is to do the really gross hacky thing of taking strings, mapping it specifically over or excuse me, actually no, I'll take I'm going to take this and we're gonna modify this real quick. So now, yeah, this is gross. There's better ways to do what I'm about to do. Don't be like me, kids. Yep, yep, Dsan, that is completely correct. I do have to apologize. I assume that your handle is meant to be read Disanji Sisa. I hope that's correct. If it's not, I apologize, and I hope that you will tell me how to pronounce your handle so that I'm not continuing to be a complete jerk. In before to do unruin this code. It's the product of you mashing your keyboard. Pronounce it however. Awesome. I don't feel like an asshole anymore. That's good. Yeah, we're gonna do strings. So to be clear, right now, what I'm thinking about is the easiest to read, not necessarily the the least expensive computationally. Multi-line map. Already that should make you feel like something really dirty is going on. I can never remember if it's flat underscore map. We want to have the original string in there just so that we can have that displayed as well. There is no way this is going to work out of the gate. But hey, let's get a starting point, right? Is it 4? Yeah, it's 4. So my hope is that the gibberish strings are all going to produce gibberish no matter what the chosen byte is to XOR against. Okay. It's real good. I'm very smart. All right, well, that was easier than anticipated. So, cool. I'm sure, and I think that this will be it for the first one of these that I'm going to do, but I think, like I said, I'm going to do these weekly, maybe every other week, I don't know. Why is the party jumping? Because we're breaking ciphers, that's why. What's more fun than that? But yeah, I think I'm going to be doing these either weekly or every other week. And again, the goal is going to be, I want to come into something either blind or, you know, otherwise unprepared. I don't want to show up and do lectures or anything like that. Because I want to show that, you know, you don't have to literally know all of this like the back of your hand to get started with it. And I want to help people to feel like they have a jumping off point. So hopefully this was fun to hang out and, you know, we talked a bunch of code. We got started on the Cryptopals stuff. I think that it's been fun. And yeah, I hope that everybody else has too. So yeah, this will be it for the first one of these, but I'm definitely going to be doing, I'll probably do this next weekend. Next weekend sounds fun. And we should be able to get through the next 4 of these so that we can finish out set 1 of the Cryptopals challenges. And yeah, as always, you know, there's Discord. We've got a pretty active programming channel, so if you're interested in getting started with stuff like this, hop in there. But yeah, otherwise, I hope that this has been good for everyone. I hope this has been fun.